Hello again. In today's lesson, we are going to review calculating the surface area of three-dimensional shapes. And so what we're actually doing is trying to figure out how much material will be required to make the different shapes. You have provided for you a formula sheet from the grade 9 EQAO, and throughout these exercises, I will be referring to that formula sheet for the formulas. They are not included on this specific handout. Okay. Even if you don't have a formula sheet with you, you can work through the process of deriving the formula on your own. Okay. Take note that the shapes that we have provided, our diagrams are not drawn to scale, so you just have to look at the information that is provided. Okay, so our first shape that we're looking at is a rectangular prism. It's a box. It is made up of 6 different faces or sides, and the top and the bottom are the same, and the front and the back are also the same, and the ends are the same. So altogether, there are 3 different types of rectangles that are used to make up this shape. So according to our formula sheet, the formula is surface area equals 2 bracket WH plus LW plus LH. And so the reason for this is that they are finding the area of each of the 3 different faces, adding them together and multiplying by 2 because the other part of the prism is going to be identical. Okay, so this is our length, this is our width, and this is our height. So we're going to substitute this information in. So our width is 8, our height is 16, the length is 20, W is 8, length is 20, and the height is 16. So I'm going to simplify what's in the brackets first. So 8 times 16 is equal to 128. So what that's doing is it's telling us the area of this side here. Okay, and the 20 times 8 is the bottom of our rectangular prism. That gives us an area of 160. And the 20 by 16 is the front face. So 20 times 16 is equal to 320. And then what we're going to do is we are going to add up these 3 numbers inside the brackets. 128 plus 160 plus 320 equals 608, 608. And then we're going to multiply that by 2 to get 1,216 centimeters squared. That is the surface area for this rectangular prism. Okay, so we're multiplying by 2 because there is congruency here. What happens at the front matches with the back, the sides match up, and the top and the bottom match up. Okay, so other variations, or sometimes you see this. It's 2 times WH plus 2 times LW plus 2 times LH. If you see this formula, this is derived from the initial formula, because what they do is they apply the distributive law and multiply every set of terms by the number 2. So in this case, you can see that 2 sides are congruent, another 2 sides are congruent, and another 2 sides, and that will also work as well. So you have options there. Now, when it comes to the surface area of a cylinder, you have to imagine what are the shapes that make up the surface, that make up a cylinder. Often that's referred to as the net. So if you were to imagine this as a label on a tin can, you could slice this open, cut this piece, and unravel it and open it up. And what you would see is that you actually have a rectangle with a circle on the bottom and a circle on the top. So what you have, this would be the net. So it's 2 circles and a rectangle that make up this shape. And so when you look at the formula for this, its surface area equals 2 pi r squared plus 2 pi RH. How this comes together is the 2 pi r squared means that you have two circles that are identical. They have the same radius. So the area of a circle is pi r squared, and then we multiply it by 2 because the top and the bottom are the same. And where it gets a little bit tricky is this part here, the area here. When we unravel this, it is a rectangle. So this part here corresponds with the height, but how exactly do we define the width? Well, this part here would fit all the way around our circle. And so the distance around a circle is called circumference. We haven't talked about that yet, but it's 2 pi r. So this here is equivalent to 2 pi r. So what happens is we take the 2 pi r and we multiply it by h to get the area of this particular rectangle, and then we add them together. So now that we've talked about the derivation, let's plug in the numbers that we have. So r is referring to the radius. When we look at our diagram, we are told that the diameter is 10 centimeters, so that means our radius is equal to 5, and the 12 represents our height. So our r value is 5, we substitute r with 5, and then we proceed r is 5, h is 12, and now we're going to proceed with order of operations. So I take care of the exponents first. Okay, so I am taking care of the 5 squared, and now I'm going to do all my multiplying first. So I multiply the 2 and the 25, that will give me 50 pi. Now I know that I need to multiply in the pi, but I'm just holding off for a minute. So 2 times 5 is 10, times 12 is 120 pi. So think of pi temporarily just like a variable. If somebody had 50 pi's and somebody else had 120, altogether that is 170 pi's. So this is an exact answer because pi is being used as a symbol to represent itself in its entirety. But what we're going to do next is we are going to approximate by replacing the pi with the number 3.14. So you can do that if you don't have a scientific calculator. If you do have a scientific calculator, you can get a more precise answer by using the pi button on your calculator. So that's what I'm going to do. I'm going to use the pi button on my calculator, and I'm going to multiply that by 170. And so I get an answer of 134.1. And because I have rounded that, this is now an approximation. So I use the appropriate symbol, which is to have an equal sign with the dot over top. And the last thing we need to do is include our units, centimeters squared. So we're starting to encroach on some of our other space here. Our third shape is a triangular prism. So when you look at this shape, first of all, figure out what are the smaller shapes that make up the prism. We have 2 triangular faces to represent the front and the back. The 2 sides, and kind of think of it like a tent, the 2 sides on each side of the triangle are equal, and we have a rectangular base. So altogether we have 5 different sides, 3 rectangles. So what we're going to do is we're going to start with the area of the triangle. The triangle measures 1/2 times the base, which is 4, times the height, which is indicated here with the 6. And we're going to multiply that by 2 because the front and the back are identical. Then let's deal with the base. The base of our tent or our prism is a rectangle that measures 4 by 12. So we're going to multiply 4 by 12 to account for that rectangular base. And then the sides. The 7 here is on the diagonal. So this is a 7 by 12. And we multiply it by 2 because the two sides are identical. And I actually haven't used a formula. I've just made sense of this based on the shapes. So now we're going to perform our multiplication. So a half times 4 is 2. 2 times 12 is 6. Sorry. 2 times 6 is 12. Times 2 is 24. So we have 24. 4 times 12 is 48. And we're going to take 7 times 12 times 2 to get 168. And then we're going to add up these three numbers. So I'm using the calculator to get 240 centimeters squared. Area is always measured in centimeters or units squared. And our last example is to look at a pyramid. Now, in this case, we have a square base pyramid. So again, without using a formula sheet, we can piece together the formula ourselves. The base is a square. So we're going to take the, and it's a 5 by 5. So it would be 5 multiplied by 5. That will give us the area of the bottom. Now, because we have a square-based bottom of our pyramid, it means there are going to be 4 identical triangles that make up the other sides. So I'm going to add 4 and put plus 4 to account for the side that there are 4 identical triangles. And the area of a triangle is 1/2 times its base, which is 5, times its height, which is 8. And now we just need to clean this up. 5 times 5 is 25. And 4 times 1/2 is 2, times 5 is 10, times 8 is 80. And we add those two numbers together to get 105 centimeters, because we're using centimeters, squared. And now we've taken you through the calculations for surface area of rectangular prisms, cylinders, triangular prisms, and pyramids.